In topic 1, we're going to talk about the chronology of development of each physics through the history of physics. Let's get started. Number 1, Aristotle. He established the general principles governing the behavior of living or inanimate natural bodies, celestial or terrestrial bodies, by applying motion, change of place, and change of size or number, etc. Number 2, Archimedes. Considered as a great mathematician of the ancient times, he was one of the first to apply mathematics to the physical phenomena, being the father of hydrostatics and discovering the principle of buoyancy that bears his name. Number 3, Galileo Galilei. Father of modern physics, his experiments and studies on the motion of bodies were precursors of classical mechanics. Number 4, Isaac Newton. He established the laws of motion that now bear his name and also the principles of universal gravitation. He contributed to optics and the development of calculus. Number 5, James Clerk Maxwell. He formulated the electromagnetic theory that unifies some of the concepts of electricity and magnetism. Number 6, Albert Einstein. He developed the theory of relativity, discovered the photoelectric effect, and did contributions to the quantum theory. Physics is one of the oldest sciences and is interested in providing knowledge, how to evaluate and discern between orders of magnitude or more. This science can develop the ability to identify the physical phenomena of nature, as well as how to confirm the laws and models that govern them, based on observation and experimental data. Classic physics, developed between 17th and 19th centuries, deals with small velocities when compared with light speed. Modern physics, developed almost during the 20th century. It considers of the quantum and relativity theories. It deals with velocity and light speed. Classic mechanics, that is almost based in Newton's work. Topic number 2, measurements and units. A physical quantity is quantifiable or assignable property that is linked to a phenomenon, body, or substance. A physical quantity is measured when comparing it with a previously known standard. Examples of a physical quantities are mass, weight, length, time, etc. A standard is permanent physical record, or easy to determine, of the quantity that implies a particular measurement unit. The magnitude of a physical quantity is defined by a number and a unit of measure. A unit is a particular physical quantity which is used to compare other quantities of the same kind to show their value. A measure of a magnitude should be carefully performed so that any error will be minimum possible, probably caused by imperfection in the measuring instrument or lack of ability of the person that is measuring. Measuring is a process that consists in comparing an unknown magnitude with another already known in the same unit or measure. Direct measurement means that the unknown magnitude is measured with an instrument of the same magnitude. For example, measuring length with a ruler. Direct measurement means that the unknown magnitude is measured through mathematical calculations performed by quantities obtained from direct measurements. Types of errors: systematic error, random error, absolute error, and relative error. A scalar quantity is specified completely by its magnitude, that it's a number and a unit. Scalar quantities which are measured in the same units can be added or subtracted conventionally. That means algebra works for them. Some physical quantities, such as force and velocity, have direction and also magnitude. That's why they are known as vector quantities. Direction should be considered in any calculation that has these quantities. Vector is the graphical representation of a vector quantity. It is represented by an arrow where its length points out of the magnitude and the tip shows the direction. A vector quantity is completely specified by magnitude and direction. It consists in a number and unit and direction. This is how you can make a vector. Topic number 4. Graphical and analytical methods for vector addition. The result of a vector sum is known as resultant vector. As you know already, this sum cannot be solved in a traditional way. That is the reason we need new methods to do it. There are two methods to sum vectors graphically: parallelogram method and tail-to-tip method. For the parallelogram method, first you have to draw with the proper scale both vectors coming from the same origin point. Then, with the use of triangles, draw parallel axillary lines that are going to touch the tip of each vector. Doing this, an intersection of the axillary lines is formed. The result of the vector sum is a resultant vector that is formed when the origin point and the intersection are joined together. The tip of the resultant vector is at the intersection. Direction is measured from the origin point. At the end of this method, we should measure the resultant vector, and using our original scale, we have to process the results to obtain the magnitude. In order to obtain the direction, we use the protector. Tail-to-tip method. It works for more than two vectors. It consists in drawing with the proper scale one of the vectors. Then where the first one ends, at the tip of the arrow, we start drawing the second vector, and we continue in the same way until all the vectors we want to add are used. The result will be the vector that is formed when you join together the origin of the first vector with the tip of the arrow of the last vector you drew. Topic number 5. Distance is the length of the real path followed by an object. It only has magnitude, so it's a scalar quantity. Displacement is the separation in a straight line between 2 points, the final and initial position, and it goes into a precise direction. It is a vector quantity, so it has magnitude and direction. To represent it in formulas, we use d. Remember that it's bold because it's a vector. Speed is the traveled distance per unit of time. It's a scalar quantity. The horizontal line at the top of variable b means average velocity. That assumes that the object is not traveling in that speed all the time. However, it is obtaining an average among the total distance and time. Velocity is the displacement per unit of time. It's a vector quantity. So the velocity shown in the formula is average, because we assume that the velocity is not always traveling in that speed during the whole displacement. Instantaneous speed is a scalar quantity that represents the speed in that instant in which the object is at a given point c. It is the rate of change of distance over time. Instantaneous velocity. It's a vector quantity that represents the velocity at any point c. This is a rate of change of displacement over time. Acceleration is the rate of change of velocity per unit of time. It is a vector quantity. We can have three kinds of graphs to analyze the motion of an object. Rate of change of velocity refers to how the displacement changes with respect to time. Instantaneous velocity refers to how the displacement of the object change, rate of change, but in an infinitesimal time. It is mathematically expressed as acceleration as rate of change refers to how the velocities change with respect to time. When this change occurs in a very short time, it is called instantaneous acceleration. Instantaneous acceleration refers to how the velocity of the object change, rate of change, but in an infinitesimal time. It is expressed mathematically as. Okay, so now I'm gonna make the vector. So 50 meters are going to be 1 centimeter. 100 meters, direction to degrees. Then -50 meters, negative x